So our next talk, and I understand why everybody's so excited about it, is on AI neurobiology of deception, falsehood, and misleading, how AI helps us understand ourselves, insights from recent research by Evgenia Alshanskaia. I'm not used to this hosting stuff. I think that I'm just embarrassing myself with everybody's last names and language names and things like that. So sorry about that.
Oh, fine.
But in any case, please go ahead.
Oh, thank you. And first of all, I have to thank the organizers and thank to Max Talanov and all of you for attendance. So thank you. And what I'm going to present, it's about, in general, it's all about you. It's about how your body, how your brain, how we are working together, and how we evaluate. So all the information, what we're getting. So it's about deception, falsehood. So I'm from the Higher School of Economics University. It's the Institute of Cognitive Neuroscience, and I'm in systems neurobiology. So it's all about stress, it's all about emotions, it's all about higher nervous activity. And also I was very pleased, and thank you to previous speakers, I was very pleased because acetylcholine and molecular shapes of acetylcholine and hypothalamus, this is my area of interest. So that's why it's so fascinating to was listening to you. It's so fascinating, and thank you for staying here. So part of my speech will be dedicated to you directly. So what's this? So what's the structure? The structure will like follows. So introduction, we will talk about your brain. So it's about your mind, central nervous system, not important, so about your head, if you want. About your body and your bodily reaction. About our own research, and I will provide interesting outcomes. Does anyone smokes here?
Yes.
Yes? Yes? Someone else? Yeah, wonderful. It will be fascinating results for you because it's related also with acetylcholine. So it will be interesting outcomes about false detection and about nicotinic receptors. So it's funny. After we'll touch gently limitations and ethical issues. So it's important in current world. Do you have an idea what truth is, what is deception, what does detector lies measures? No? So I will add some key concepts about this, about previous research. So usually it's important how we measure, how we evaluate what lie is. Because sometimes, so we could be take per day it's 1 or 2 lies, or maybe every 10 minutes. So it's kind of habitual lie. And what is really important? It's important to understand that deception, half-truths, if you have exaggeration, omissions, or even generalization could be taken like lie. And what motivates us to lie, to mislead someone? First, of course, it's self-serving lies. It's an interesting concept also. For dating couples, wonderful research. So it's here in motivations. So the third time of communications dedicated to lie, mutual lies. So could you imagine? It's mainly about feelings and plans. So it's how to say, deception could be very beneficial. So you maybe agree with it. So about gender differences, it's important because women are prone to more altruistic lying. So and more prepared lies. So we are prepared. So we are rehearsal our lie, and after we're going to to provide it to others. Compared to men, more self-serving and more, more related to current situation. So if men, of course, it's generalizations, so excuse me for my lie. So if someone see the opportunity, the men more prone to try to catch it by using lie. So also it has physiological aspects. For example, this is a very interesting fact that lying activates areas associated with planning and self-control. That's important. So sometimes when your kids, your teenagers lie to you, it's kind of rehearsal in general because pathological liars, habitual liars, they have increased prefrontal cortex white matter. As you know, the gray matter is neurons. White matter, it's glial cells. That's important for taking care about neurons. So it's increase the speed of signals providing. And the brain regions, you know, it's a lot of brain regions in this anterior prefrontal cortex, anterior cingulate cortex. I will delve deep a little bit later. And what lie is from the neurobiological point of view. From a it's about matching and mismatching the information. The two different parts of information, you see the external source of information and internal source of information. On the axis, you see the highest level of confidence and authority of your source and the more low level. So if, for example, you absolutely agree with external source, you will take it as a reliable truth. And the opposite situation, and this will be focused on, it's about mismatching. For example, if your external source, people or media, for your professor maybe, or your friend of yours, provide to you some information, you don't even try to check it. Usually you believe in it. And the opposite, if you don't believe, or if it's not very good paper, not very reliable, I don't know, publishing house, yes, it will be taken like fake, misleading deception. And we have a special department, so with Klucherov, Monachova, and they're responsible for research. How it works in your parietal lobe, in the back side of the brain. So it's focus, of course, I'm simplifying. So it's also subcortical regions involved in this, and hippocampus and others, previous experience and beliefs. And in front of your frontal lobe, it's collecting all the information from your body, from your long-term plans, from your short-term plans, and evaluate it. And also, for example, you have something wrong with your brain-gut axis, you could make worse decision. Increasing level of your blood sugar also could misleading you and broke your previous ideas about what you are going to do. So, and anxiety also related with a higher blood sugar level. So, and in the center and singular cortex, we evaluated it and it's responsible for comparison. What else brain areas? If you take a look at the image at your top right, prefrontal cortex we just discussed, left and right amygdala. Anyone know what's this? What amygdala is? So it's interesting, it's like a switcher between how you are going to react. So it's emphasizing or decreasing the reaction. And your left amygdala, it's usually provides and evaluate the information from something familiar. For example, our linguistic centers were placed from the left side. You know, it's a very tricky thing. And our right amygdala, they're growing till the end of our life, and it's most suspicious part. So how we are taking information also involved hemispheric differences between left and right amygdalas. Cingulate cortex, you see in the bottom left, and this is my one of my favorite spot also. It's hidden part of your brains. It's insular cortex. It's responsible for all your immune system, for collecting signals from your gut, from your old inner, environment, from your environment. Also, for example, if we are trying to evaluate romantic relationships, we love to, if we love someone, we're afraid to lose this person. It's about jealousy also. We hate to spend money, for example. Insular cortex also responsible for this. So it's very funny, very tricky. And now all the future research in neurophysiology, there, it's a bunch of research dedicated to insular cortex. Very fascinating. And all these regions regulates how your body works. Your body reaction. You can skip, you don't need to delve too deep in this. So what's the problem with fMRI PET, as was previously said by the previous speaker, is too complex, too expensive, and spatial resolution, fine, but time resolution, so it's not enough information. We need something more frequency updated. It's also, you know, you have to real-time evaluation. It was prepared especially for our Chinese friends, so it's attempts to understand ourselves find centuries ago, from centuries ago. And what we have now, so it's everything already described. So here, maybe you see, this is your, do not delve deep, it's the idea. This is your rest and digest system. And this is a fight or flight system. So we know every single receptor. We know every peptide. We know the molecular structure. So all your body could be digitalized in general. So just we have no time for this. This is our own research. What was the aim of our research is to understand about so-called subconscious understanding of life. What's this? It's about how your body and your brain, the eye, because we used eye tracking, perceive information and evaluate without understanding. Is misleaded, it's false, or how it works. The procedure, it's very simple about eye tracking, as previous speaker said. It was pupil size, dynamics, it's a bunch of parameters. Of course, it's simplified, so we took about 200 parameters and compare them. So pupil size, fixation, saccades, heart rate variability, it's how your heart works. So it's parameters and it's a good math underlined. Skin galvanic reaction. Usually light detectors, they use skin galvanic reaction. So because it's also, you have to know it's a lot of mistakes about this because it's cholinergic innervation. Breathing parameters, cognitive metrics like time of reaction, amount of mistakes or errors, and self-esteem, how people evaluate themselves after they're completing the task. And self-reported data, all the medical anamnesis, all if they took some drugs or they have some issues with their health or hormonal system, we collect all the data. So, and the questionnaires, training and questionnaires again, to compare all the questionnaires about anxiety, about stress, about depression, about how do you feel before and after. So, the false feedback was in a block second when, for example, you are doing well, we provide to you opposite information. So this was a hidden false feedback. So people don't understand, and we were trying to investigate what does it mean. Oops. Oh, I'm sorry. Okay. So about the data, what was registered. So this is all we didn't measure it directly, but we paid attention to this because in our previous research was shown that your photoplethysmogram neuroadrenergic response and your heart response vary to people who have anxiety, panic attack, to people who have anxiety, depression, and panic attacks. So also we could evaluate and could provide your information about yourself, about your current mental states. So the data processing and analysis, we used unsupervised machine learning, and we took very simple and robust K-means clusterization. So ELBO method showed to us two clusters. What was the main problem? What was the most difficult thing in machine learning when you're working with your bodily reactions? It's signal processing, because you know it's 1 year was spent to find the algorithms without reducing, you know, all the peaks or doing extra smoothing. So what was used and what was the best decision for this for body processes analysis. It's Python NeuroKit, MIT, very good decision, and combined with BioPsyKit, extra peaks removing for different parameters. So it's important to understand. And it's a bunch of parameters what was measured. And this is the outcome, result, what appears. We found two clusters, and you see here the increasing difficulty. You see, there is no reaction to increasing difficulty. Here, in this one, this yellow part, it is a part with deceptive false feedback. You see, this is existing reaction here. There is no pronounced reaction here. So, what in our parameters and setting and properties of people? What also described with clusters. First of all, it's here, it's Epworth test. It's no anxiety, no breathe rate, no skin galvanic reaction, doesn't work. But oculomotor parameters and heart rate parameters, they work perfectly, just perfect. So what's this? It's Epworth test. It's how we measure daytime sleepiness. So if you feel sleepy during the day, so the highest rate, it was the cluster 0. They were more sleepy compared to other one cluster. And now one, smoking habits. I've told you, I promised you that. So in this cluster was most people prone to smoke. So more smokers and more clusters. So something has happened, and less pronounced reaction to false feedback. So also pay your attention here, the false feedback parameters that was in cluster 0, more sleepy and more smokers inside this cluster. And you see so the parameter in heart rate and saccades, so and normalized pupil size. So the most pronounced reaction was in a cluster with less smokers and less sleep, wish to sleep. So the conclusion is, what's good? For what it could be used, we will discuss after. But the conclusion is simple, non-invasive solutions. And as you know, maybe now existing the software in GitHub, when you could, which is quite good for measurements, real-time evaluation. Your pupillometry, and simultaneously you could withdraw information from the vessels that pulsing in your eye. So you, from the same just web camera, it's so, and that time resolution, it's more than enough to evaluate deception, mismatching. It's not a deception, mismatching information, how you evaluate it. It also could be taken as a protection from deepfakes, because deepfakes, they have no pupillometry fluctuations here. And now it could be used also for deepfake protection. So what else could be measured? Also non-invasively, with machine learning approach and artificial approach, facial expressions, voice, and behavioral patterns. Like that's really good for neuroeconomics as well, especially for someone who will discuss it. What's the real-world applications? Of course, education. If you know your optimal state, if you know in what particular condition you are right now, you are able to decide. You know, you want to do something that is really resource-consuming, your brain resource-consuming, or something more simple. You know, like something regular, something traditional. So occupational. Also, you see exhausted your employees or not. So it also could be measured just using only webcam. Remote mental health controls for professionals, because as we know, heart rate variability changes with cognitive decline, for example. So personalized therapy. So you know this type of therapy was beneficial for you or not. So you see the measurable results, not some abstracts, not conclusions of your therapist, not your own. So you can measure your condition. So, and it's good. It's very good for self-mental states and condition control. Issues, ethical issues, always. The privacy, of course, it's sensitive personal info. It must be protected in some way. concert and how we keep all the information, misusing, the risk of misusing, data security, could we share it? For example, like companies who provides, your DNA analysis, they could sell it to to big pharma companies. And must we protect our biological info as well? So interpretation, because now all the guys who are working with lie detectors, usually it's the core issue in the narrowest part is the matter of interpretation. And emotional impact, when you understand that you are supervised, of course your reaction vary. So, but all what could be used will be used if someone will invent something and no one will share it. So let's do it ethical and secure if it's possible. And thank you for your valuable attention. If you have questions, you are welcome.
Thank you, Evgenia. Do we have any questions?
Thank you.
Thank you for a very interesting presentation.
Thank you.
I have a few questions, mostly about data collection. So how can you isolate some specific signal and attribute it to some certain behavior? So for example, if you are tracking eyes, how can you be sure that some change is attributed to person lying and not to some other change? Do you have to isolate the subjects in a light control, for example, scenario? And I'm interested in that part, so maybe you can tell us about that.
Yes, very good question, thank you. The point is that when we are in experimental conditions, of course, we are filter all of this. But when we are able to withdraw the core features, for example, wearable devices. So it's a lot of software created, for adjusting signals for environment, it's also special chains, the current chain. So it's a measure of implementation. Of course, we have to, try it, we have to verify all the data. Yes, but now it's possible, especially if we withdraw the principles from the signal processes of heart rate variability from wearable devices. It's very good state of art there, yes.
Okay, thank you. My second question is, so what kind of hardware do you need? It's related to the first question. So could this be used, for example, one very interesting use case would be in the cars. So to measure drivers' attention, tiredness, and things like that. So do you need some special equipments like, for example, stereo cameras, so you see both drivers' eyes and things like that, or nothing special?
It depends on your technical, how to say, approach, because someone likes, to verify everything around, but sometimes it's not necessary. And if it's important to find the core features that are most useful, so you don't have to verify everything around. And even our web cameras in your cell phone or your notebook cameras, it's more than enough. Yes, but we have to verify the data. So it's already a matter of software. So
do you think in the future, like for teleconferencing, for example, you would be able to have like Google Meet and a lie detector?
Yeah, absolutely. Yes, you are thinking absolutely you are in the right path, because it could be combined with your Google Meet or Zoom or something else. So if you are, for example, potential employee, so it's possible. But also I have to highlight, and that's important. It's not about false or deception. It's about mismatching information. For example, to lie at foreign languages, it's easier, because you have this, this gap between us. So the same it's also, the human resource managers, we are definitely biased. In general, all we are biased, so it's a matter of interpretation there. But we could get information, and for example, we understand that a level of arousal of one candidate, just permanently higher, yes, and compared to others. So it's all also must be focused on personalized approach.
And last question, if I may. So sorry, in one of your slides, you had like some biological differences. I think it was one of the first ones, maybe slide 4, if I'm not mistaken.
Which one?
No,
12?
even before that, before. Slide 5 then.
5. Okay.
Yes, this one. So pathological liars have some different biological differences.
Habitual, not pathological, but habitual.
So it's very interesting what you said about white matter being linked to like speed of thought, for example.
Yes.
So does this mean, is there some correlation or is there some research to link intelligence with probability for somebody to lie? In other words, do intelligent people lie more than non-intelligent or less intelligent people?
It could be one of characteristics. It's, so I will not provide you immediate response on this, but it's what lie is, what could be taken. It's a way how you adapt your behavior or your plans to environment around you. So intellectual systems, the core idea about intellect, maybe colleagues will fix my mistakes, but it's also about adaptive behavior in different environments. So so if you have some profits from it and you have to survive, you know, you have to join with someone to create a new group or either doing something. So it's important because you have to decide fast. As fast you decide, it's increasing the risk to survive in general with your survival rate.
Thanks.
Thank you.
Do we have any more questions?
Okay. Thank you. Thank you.
Hold on. I have a question. Can we go back to the 2 clusters?
Oh, yes, please.
I'm very curious about that because I'm not sure I completely understood that graph.
Yeah.
So what we have here is two groups of individuals.
This is how your pupil works. You know, it's clusterization. So it's
right. But what was this? So these people above, they didn't experience stress with the increase of the complexity?
Both of them, it was clusterized the same group of people, and it was how to say, grouped autonomically. Without usually scientists, you know, spread, define the groups. Here, it's how machine learning, unsupervised machine learning algorithms did it, and just after what was recognized about sleeping features and smoking features.
I get that, but just to understand these two, so the people that didn't, so we
have
to
the same. Yes, it's absolutely the same condition for all of them. So, but the reactions. Yes, very.
So the ones who didn't experience stress from the increased complexity, they didn't?
Yes, they didn't respond. Here's the increase in complexity. You see, there is no pronounced response to increase in complexity. This for smokers and prone to
I would say that smokers, just generally speaking, are more resistant to stress, physical.
Yes, but in general, you see also interesting fact that heart rate variability here higher for the heart rate variability was higher for smokers.
But that's because smokers generally have a higher heart rate variability.
They're more calm. So, of course, generalization, the smokers more calm.
Right. But again,
so
it's because
the core idea, if it's to be sensitive to false, deception, misleading, your sympathetic system. Like a fly and fight system, have to be switched on. Otherwise, if you are too calm, you will not be so sensitive to misleading.
Right, but like my interpretation there with the smokers would be because once you, I was a heavy smoker, once you finish your cigarette, it takes approximately 15 to 20 minutes for the stress to rise again.
The heart rate variability was significantly higher. And I don't delve too deep because your brain also works differently. So it's
all right, good stuff. Anyway, if
Thank
we have
you.
no more questions, thank you very much.
Have a good lunch. Have a good meal.
Yes.